Now we need to, as I said, put these together into one totality, one schemata. We've got 3 sets of measure formula, and realize that with these 12 measure formula, we can completely solve the problem of moving bodies. We have the entire vocabulary needed for the physics of moving bodies. And incidentally, we can even anticipate the famous formula E equal mc squared. See, that's exactly what this is, because mc squared, what's c? C is a velocity, i.e. L over t, and we have here L over t squared, L squared over t squared, m L over t squared. That's mc squared. And that is, as I said before, energy or work. E energy equals mc squared. So the measure formula anticipated this famous formula of Einstein. Well, how do we put them all together? Well, that's very simple. In this set, since we went around in 4 steps, we were using time, division by time, as taking 1/4 of a circle, so that when we took 1/4 4 times, we had completed the whole circle. Now what I want to do is come to the next set, which is this one. How do we get, you see, we have the first set here already. How do we get to the set multiplied by m? Now, if we take m as 120 degrees, of course we can't be 90 because that would simply duplicate what we had before. This is 90, so let's take 120 and get to a point here. In other words, call this m L over t squared. I should have made it more. Now, I'll use the same rule for multiplying by m here and get, this will be m L over t. Same one here. M L. And the same here. M. They all have ML, see, but this one is divided by t cubed. I've added the second set, so I'll put that away. Now we need to put in the third set. And if I make the convention that L is 30 degrees, I can fill those in. 30 degrees, see what I've gone 120 degrees, so since this is 180, there's 60 in here. So half of that will enable me to put this one multiplied by L, which will be mL squared over t squared. That's not a very good 2. That's this one. This one will be mL squared. They're all mL squared now, but this is over t. This will be mL squared without any t. And this will be mL squared over t cubed. Now I've got the 12 measure formula all arranged in this circle, and my convention is that t equals 90 degrees, mass equals 120 degrees, and L equals 30 degrees. That is what I call the Rosetta Stone, because it enables you to translate the measure formula of physics into English. And this is my attempt to do that. Now, some of these, the English words are going to be the same. For example, control stays control. Work can stay work, but for the purpose of further, as you'll see further, it's going to translate into fact. I'm afraid this is going to be a little difficult. Perhaps I better go more slowly, and perhaps I better follow a distinct order. Let's go back to the first four. That would be these and these. Remember, I started with position. Well, position is something you observe, so I'm going to use the English word observation there. Velocity is the rate of change. Now, in physics, it's the change with respect to time. But let me take the liberty of referring to it as any change. That is actually what Aristotle meant by change. He didn't mean velocity, he meant any change. Now, the rate of change, which for the purpose of measure formula was acceleration, becomes, in English, it's the spontaneous act. It's that which you do when you jump or when you change something. It's generally the start of things. Control, and the fourth of these four, I can keep the same word. So much for the first four. Now let's look at the second four. That was this set multiplied by m. I'll put it here so we can see. Remember, I started with force. That's the one that came from here. When I multiply the acceleration by mass, I get force. Well, the English word for force could be being. It's just that great thing that is there that makes a person forceful, their beingness. The next one, multiplying velocity by mass, which gives you momentum. Momentum is the way you transform things. You want to break the vase, well, you hit it with a hammer, or you want to drive in the nail. Momentum, this impact, results in change because it really comes about because this it's not the same as force. The force is something that's being exerted. Momentum is that which makes things change. So that's why I call it transformation. I'll show you in a minute another way you can check up on these relationships. We want to finish, though. Now, observation, which was the third one, and which when multiplied by m becomes moment, I translate that as significance. And that's, well, it's almost a pun, but it's a little better than a pun because you say things of great moment, you mean things of great significance. But also use the term leverage in just the same sense. you have a lot of leverage if you have significance in a situation. And it comes about in much the same way. It's not just mass, it's the distance multiplied by mass. The thing has more leverage if it has a longer reach. It leaves only this one more, which is not used in physics, this one, multiplying control by mass to give mass control, and I call that establishment. It's getting the thing right into place, and it suggests mass, because suppose you were lowering a piano or a large weight with a crane. You want to get it exactly in position. What counts is not only the mass of the thing, but your control, or the other way around, not only your control, but the mass of the thing you were controlling. It would mean a lot more to get a steamship into dock than to get a rowboat into dock. In other words, the control has to be multiplied by something that gives it more oomph, and that's the establishment. So I finished this set. Fortunately, the last set is easy because these are the ones we talked about originally when we were looking at the triangle, remember? It may seem far-fetched, but when you see the English words, you'll see that it works out. I'm talking about, let's see, I first did this one. That's this one, work, and power. I better show how I got these. I came from here to here to get work, from here to here to get action, from here to here to get inertia, and from here to here to get power. Now I want to relate those to the original set of four. Remember the knower looking at the triangle. Now, the exact data in front of him, the objective information, was that it is a triangle, 3 sides or 3 points joined by lines. That would correspond to knowledge, this one. His belief that his feeling about this, that he didn't like triangles, would fall in the category of, well, perhaps the word would be belief. I have the word faith there. It's the inertia of his past associations carrying him along. The one that was opposite that, do you remember the projective one was at the top, but the information coming from the triangle to the knower, which was at the bottom, that was fact. That's why I called this one fact. The triangle has a dent in it, or something particular about this triangle that's fed from the object to the knower. And it almost always involves some work, because you have to look carefully or you have to do something to find what the facts are. Whereas the belief is inertia, you just let go what's in you. We can think of each of these as having a positive or negative value. For instance, if something was completely false, not factual, we would normally think that's negative. But on the other hand, if you were writing a novel and it wasn't made up, it wasn't created, then you would say, well, this is simply a description of a life occurrence. It isn't a novel. So the word novel implies that you've made it up. So in one case, this is to be In other words, the negation of fact is positive here, and this is the negation of belief. The fact contradicts your belief. I hope I'm not getting too complicated with this jumping around, but you see, we're trying to talk about a whole lot of things at once, and if we don't jump around, we wouldn't get the real meaning. The meaning comes from the interrelationship of these things. And what we now propose is that with these English words, we have a complete vocabulary that tells you the same thing, but in terms that we can understand, or terms that can be applied to people, that the measure formula did for physics. Now, what we have to recognize is that physics came by these measure formulae the hard way. It began when Galileo was measuring the weight of, or the rate of falling of bodies and rolling things down inclines, and when Newton was carefully computing the motion of the planets. These measure formulae were born, and they were carried along and gradually evolved as the complete vocabulary of the physics of moving bodies. Now, people would say, well, what's that got to do with life, or with life as we live it, or with human affairs? Well, what I've discovered is that it has a lot to do with it. Let me go back to our original diagram and erase in your mind these ones I've added and just think of those, the original four. This one, which is the position, remember the pendulum now. The position is something you see. You could take a photograph, a single photograph, and it would show the position. To get the velocity, you have to take two photographs and measure the distance between the distance the object has moved in the interval between the photographs to be able to estimate the velocity. To find the acceleration, you'd have to take three photographs. Let me illustrate. Suppose I take two photographs, and in one the object is here, and the next one the object is here. You say, well, it's moving in a straight line through those 2 points. But it might be moving in a circle. A circle could go through those 2 points. You've only taken 2 pictures. So you really don't know whether it's accelerating, that is to say, going in a circle, or whether it's not accelerating, which is going in a straight line, just from 2 pictures. So to know that it's accelerating, you have to take 3 pictures. In other words, if the picture was 1, 2, 3, then you would draw a circle through those 3 points and say, well, it's accelerating in a circle of such and such a radius. It could be a car with the steering wheel stuck. To know that it was under control, you'd have to take 4 pictures, because if they went 1, 2, 3, 4, so that the 4th point was still on the same circle, you say, well, that person's going in a circle. There's no evidence of control. Maybe the wheel is stuck. But if it went 1, 2, 3, 4, well, that would be a line like that. In other words, somebody's changing the steering. This would be the case even if you just went around a corner and then straightened out again. That means that the control is being exercised because the acceleration is changing. Well, I want to stand back from that now and, as is my custom, look at a deeper significance, because so far I've just been talking about what the physicist measures and deals with. I started by saying that we see the position with one photograph. With the velocity, I have to have two photographs, and I have to compute the velocity. There's no instrument that directly measures velocity. Even the odometer or the speedometer on a car, to do it accurately, it has to count revolutions per unit of time. In other words, it has to make a computation to arrive at velocity. So velocity involves something more than just seeing. It involves computation. When we come to acceleration, while it's true that you can formulate acceleration as the rate of change of position, the rate of change of position, acceleration is directly felt. Suddenly the elevator, we just had an earthquake the other day, you feel it in your bones. If you go down an elevator too, suddenly you feel it in your stomach. In fact, you're always feeling acceleration. That's how you're able to stand up. There are these channels in the ear, these canals in the ear where very delicate apparatus senses any acceleration that would tell you when you're tipped. In other words, you feel acceleration, you compute velocity, you see position. Now here are three outstandingly different faculties epitomized in these three measure formulae. So this is not something that's just going on in physics. It's something that's common to all our experience. In fact, in this, I believe, we have the roots for the difference between seeing, knowing, feeling, and the one that I haven't talked about, which is action. Action is this one up here, or this one here. There's a distinction between them, but for this purpose I can put these two together. The control is, remember, control was not used by Newton or by other scientists because that came from outside the system. But it's because of control that we can use a car. However, there is no way to anticipate what the control is. That is up to the option of the driver. And that's the whole virtue of control, that it's the free element in this fourfold, among these four, it's the one that's optional. That's what makes it possible to control these machines. And we've given it status by showing it's what its measure formula is. But giving it a formula doesn't mean we can predict it. So, summing up then, we have a sort of preview in physics of what become the four faculties. And this is another four-ness that I didn't mention earlier, but Jung, the psychologist, made a great deal of use of what he called the four functions. He avoided the word faculties because he felt it had been rather abused by previous psychologists. But making that concession, then the four functions of Jung are knowing, sensing, feeling, and intuition. Which set will I use now? I think the best set is back to our original diagram. The knowing of the definition, the concept of a triangle. The feeling, I don't like triangles. The sense data, the sensation, this triangle has a dent in it. The intuition, I will use triangles to represent Father, Son, and Holy Ghost. You see, you can't anticipate what this purpose will be. But I've represented the four faculties now from these and traced their origin in the measure formula, in these things. That takes us back. We can now go back to the Rosetta Stone and see what it's really talking about. It's saying that there's an English vocabulary that corresponds point for point to the vocabulary of the physicist. And the English words have very much the meaning of the physicist's words, but sort of broadened out. I'd like to play with it a little. Why is faith like moment of inertia? Well, faith is what you have to have when the going gets tough, when your push gives out. You have to have faith to keep going. That's exactly what the moment of inertia does. If a car didn't have inertia or the flywheel wasn't there, then the car would go by a series of jerks as each explosion occurred. It's because of the flywheel, because of the inertia of the car, that you get smooth motion out of jerks. And faith is very valuable in just that sense, that it tides you over the bumps. You see, at the same time, faith is opposite fact. In other words, as the Irishman defined faith, oh, sure, faith is believing what you know ain't so. The facts might be otherwise, but there are times when you have to have faith and run counter to the facts. So it's called in psychology counterfactual. In other words, when you learn some principle and get it have sufficient faith in it, that even when the principle seems to be denied, you have faith and go ahead. Now, knowledge is not the same as inertia, and it's not the same as work, but it's through knowledge you're able to translate this into this. This is what mediates the inertia. But there's one more principle that's necessary, and that's this one that's opposite to it, action. And that's the one I haven't talked about. It's really the most important in the whole picture. Action corresponds to making a decision. You see, it's opposite knowledge. It also corresponds to intuition among the Jung's four functions. It's sort of jumping to the answer without having reasons. Remember Sikorsky's little picture emblem on the helicopter? And the emblem shows a bee, and the script says, according to the theory of aerodynamics, the bee can't fly. But the bee, being ignorant of aerodynamics, goes ahead and flies anyway. That's what is the virtue of this principle. It's the opposite of knowledge. It's ignorance, but it's the power of ignorance. Knowledge is, so to speak, the inert thing that cancels the energy of curiosity. I suppose people will eventually learn that teaching is not so much giving people answers, but encouraging their curiosity. And a similar reform might be applied to whatever it's called, social welfare. The idea of social welfare is generally that you supply goods to fulfill people's needs. But the whole principle of evolution is based on creating needs. It's through needs that people exert themselves. So if you were to fulfill all needs, you'd stop the wheels of evolution. However, that's just something to think about. I'm illustrating how these so-called negatives, that is, lack of knowledge or ignorance, is a power, and the lack of goods creates the energy or need. This would be need over here, and this the actual object. Now that completes the English translation, but there's a further dividends here, because we can recognize that this 12-fold division of the circle is nothing other than the zodiac itself, the famous zodiacal signs. And the simplest way to get into that is to think of the months of the year. This is spring, when the growing things burst into life, the first burst of energy of spring. And then as spring gets underway, things start growing, and by summer they're at maximum rate of growth. By fall, the growth has stopped. This is going the other direction. We're slowing down and looking to see where we are. And at the middle of winter, we have to control our resources and be very careful. The other signs you can recognize, whether through the season or through the months. This is Taurus, establishment. Gemini, knowledge or power. Cancer, which is change. It really helps to have these key words, because Shakespeare said, he was born under the crab, sir. All his affairs move sideways. Well, the crab moves sideways, and that's the key to this kind of change. You see, it's sideways from the point of view of the original thrust, which was this way. This is now this way, at right angles to that. That's the way it was intuitively felt as sideways, and why people selected the crab to represent it, because the crab wiggles along sideways rather than forwards and backwards. Then we come to Leo, which is force or being, and of course Virgo is well described as work. Libra is position. Libra, the scales. You're looking at the scales and making a judgment. You're seeing what the position of the scales is. Here's Scorpio, momentum, transformation. And here, this very important one, action, impulse, that's Sagittarius. That's the power of ignorance. That's why Sagittarius is related to gambling, but also to higher philosophy, because you're guessing. You're jumping into areas where you're ignorant. Of course, when you come to here, this is Capricorn, famous for its controlling the situation and the sure-footed goat. Aquarius, significance. That's a very good definition of Aquarius. It has to do with principles. The opposite of being, you see here, the being is the actual force of being, whereas this is the significance. In a sense, it's non-being. I always think of, well, the unicorn is a representation of this this sign, this type of mode of being. Why? Because the unicorn has this horn, unique horn, one horn. it starts out as two horns, but they curl around each other and come to a point. They focus right on the issue. And that's what this is, significance, focus. It's the opposite motion to what you have here. Do you call it being or Leo? That's the sign of the sun. It means radiating out. The sun is always shown with these rays going out. That's the being. It radiates outward. It's centrifugal, whereas this one is centripetal. It's getting to the point, coming down, focus, significance. We've only one left, which is Pisces, faith, inertia. So we're in the Piscean age, the age of faith. I can't resist the comment that the age of faith normally suggests religion. How come we're in the scientific age now? Well, science has become the religion. And most people, and I might even say most scientists, have a faith in science that won't permit them to recognize, say, the facts of ESP or other facts that would falsify the hypothesis of science. The Piscean age, therefore, turns out to be religion in spite of itself. Despite science's effort to get away from religion, it turns out science is just as Piscean as other religions. It's a faith. Well, that wraps up the Rosetta Stone, and I think I might call attention to something I've skipped. I was trying to get along with this, and I left out what I call in the book three-ness. The three-ness is essentially this jump from number one here to this one, which is mass times that first one, then to here. So if I took my pencil, I don't know what I've done with that darn thing. Well, it seems to have evaporated. If I finish out this triangle, I think of these three things. Now, that's taking one from each of these sets. You remember. The L over T square, the ones multiplied by M, the ML over T square, and the ones multiplied by L. Now you have to notice that when I made this first, I multiplied by L. But if I'd multiplied by L divided by T, no, if I multiplied by LT, I'd get to here. In other words, this 3, it really means that these sets aren't on the same line. They're on the same line from the point of view if I multiply by L, but if I want to keep them in sets of 3, I have to jump one row and look at these 3 together. In terms of astrology, these are the 3 fire signs, Aries, Leo, and Sagittarius. Similarly, these 3 are the 3 air signs. Gemini, Libra, and Aquarius. These 3 would be the 3 earth signs, and these 3 would be the 3 water signs. If I put it all on, it gets kind of mixed up. But the 3 go together, and this is what I left out in my account. See, when I described acceleration, position, velocity, I was talking about the things that are at right angles to each other. And in a sense, this isn't the most natural way for them to occur. The most natural way, the free-flowing way, is the way they occur in life. For instance, you encounter a stimulus, you do an act, and you get a result. That's jumping by 120 degrees, so you go around this thing in 3 steps. That's one of the reasons that trine is so much easier in an astrological chart. It's a signature of easy flow from one thing to another. Well, let's think of the three-ness then by itself. Suppose I walk through the door naturally to get to the other side. Everything's all right. But if the door happened to be locked, I couldn't walk through the door. Or suppose I pushed the door and it didn't respond. Then I stand back and look at it and see the sign saying pull. So, rather irritated, I pull the door and get through. Now, the first act where I just went through the door without any trouble would be an illustration of three-ness. The second, where I have to stop and think, is an illustration of the four-ness. See, if I went through the door, I'd go boom, boom, boom. But if I have to stop and look, this is the looking, this is the changing. I have changed my technique, and then when I know how to change it, then I control the door and open it. But it's taken all this time to learn how to open the door. So the four-ness comes about when you have to learn something. The three-ness is what occurs naturally. Now we're ready for another big step, and then we'll be close the geometry of meaning. I've been using this Rosetta Stone in a way that must have appeared to get more and more complicated. Now I want to put it all together and use it, and you will see that it'll become very simple. This is a way of spreading out, you might say, all the information you need. But as with any spreading out of information, what do you do with it? Well, for this I need another diagram. We recall that the Rosetta Stone started with this four-ness, to which we added the three-ness, and the 3 times the 4 gave us 12. Now let's go back and think about, let's say, the problem of going through the door. The difference between the three-ness, which was the natural stimulus, action, and result, where there is nothing to prevent your going through the door, versus having to learn that the door opens by pulling rather than by pushing, which is a 4-step operation. Now suppose you've learned all that. This is also the problem of explaining life. It's the same problem that the turn introduces in the reflexive universe. What is it that happens when you've got all this 12-ness figured out? I use the story in the Geometry of Meaning, taken from Charles Lamb, about how cooking was invented. It seems that barns were struck by lightning and burnt down, and sometimes some of the pigs got caught in the barn, and the result was roast pig. And then people found that roast pig was much more delicious than raw pig, so they burnt down barns on purpose to roast pig. And then they found they didn't have to make such a complicated barn, they could just make a fire and roast the pig in the fire. Well, this seems very elementary, but it actually is very complicated from a mathematical point of view, from the physicist's point of view, because what's happened is we've reversed cause and effect. See, the fire causes the roast pig, but somebody thought and said, well, if I want to roast a pig, I have to make a fire. Now, in that case, he thought the roast pig was the first thing that came to his mind. And it was the roast pig, or the idea of getting roast pig, that caused him to build a fire. And then he got the actual roast pig. Do you see the sort of V shape there? We go from fire, cooking imaginary, to an actual fire, to cooking real. And this is somewhat the same process we were involved with in the theory of process, that purpose finds means to achieve its goal. But the difference between cause and effect and inference is what makes the difference between the left and right-hand side of the arc. The left side of the arc is committed to time's natural flow. Cause precedes effect. But the other side, where you think what you're doing, the effect precedes the cause. Really what I mean is you use inference on the right-hand side. You infer that the fire will cause the cooking. Another illustration, in actual fact, a fire causes smoke. But then you hear the expression, where there's smoke, there's fire. From the smoke you infer that there is a fire, and that's the opposite direction to fire causing cooking. Well, to carry on then, how would we represent natural order? It requires that there be three things, like A, B, and C, because you can say the order is A, B, C. You can then indicate the reverse order by saying A, C, B. Now this would be illustrated by A, B, C, but the reverse order would be A, C, B. Do you see one? This one goes counterclockwise, and this one goes clockwise. Now recall, I didn't give it today with the geometry of meaning, but I've mentioned it elsewhere. The cycle of action begins here and makes a mistake, learns from the mistake, and then is careful. But if you proceed in the opposite direction, which gives you this diagram. In other words, you start at 1, learn, make a mistake, think about it, and then control your action. And instead of going on to a new level of action, letting this knowledge become unconscious, you start to apply your action. You go in the reverse direction. That is to say, you began by going counterclockwise, you turned and went clockwise. This would be cause and effect, this would be inference. Now those two motions, cause and effect and inference, come about because you have this threefoldness which you can turn either way. It's what I call the zero dimension of choice, the capacity to choose to go in either direction. This is how intelligence, purposive intelligence, can use the Rosetta Stone or the formulas or the knowledge that it's acquired, how it applies this knowledge and regains the freedom that we discussed in the reflexive universe or the theory of process. That is very simple, but it's somehow subtler than anything I've ever found in a physics book. Let me try to explain it in terms that might stand up to a logician. I'm partly remembering Hume. Hume was a philosopher who startled the world by saying, we have no evidence of cause and effect. We have to assume it. He was thinking of the world in this logical sense, that the cause and the effect are related, but the time sequence can't be logically expressed. The time sequence is a matter of our inner experience, not something out there. Time isn't out there. At any rate, Hume had made such an impression on philosophers that I think this is the place to take off with our argument, because it really involves this point raised by Hume, that we can't know cause and effect by science. We have to infer it. Well, I don't agree with him. I think it doesn't, but that doesn't matter. What is the point? The point is that in the mapping that you make of relationship, there is no way to distinguish which is the cause and which is the effect. You simply say that these two things are interconnected, and you don't have time to order them in one way or the other. The time ordering comes about through this threefold, and it's through the threefold you can distinguish between going from cause to effect or from effect to cause. It's the difference between turning this way and turning this way. See, cause and effect really doesn't quite, you need three terms to make the distinction. I think stimulus, action, result are the three terms. And if you do it the other way around, you go, instead of A, B, C, you go A, C, B. In other words, the static picture which the intellect presents, which is represented by the four-ness, which is a mapping of interrelationship, needs the motion picture, the moving, the time picture, which gives the ordering and tells you which comes first. And this also explains the arc. I'm referring to the theory of process. The difference between things falling, coming about in the natural order, for example, entropy. One of the laws of thermodynamics is the law of entropy, that order gradually gets more and more distributed. Stones roll downhill. Hot things get cooler and cold things get warmer. Things tend to average out. That's known as the law of entropy, and it's one of the laws of thermodynamics. But when a plant grows, it violates the law of entropy. Not only is it storing energy, whereas the law of entropy says that energy gets dissipated, but it's building up. The plant gets higher and higher and higher. It's like a mountain building itself. Of course, a mountain couldn't build itself. A mountain would roll down, gradually wear out. But the living thing has this possibility of moving against the flow of entropy. It's called neg-entropy. And that difference between entropy and neg-entropy is also the difference between the ordering ABC and ACB. Well, I think we can now make a summing up for the whole geometry of meaning. The geometry of meaning is a way of displaying meaning in terms of angles, and when we follow it through carefully, following what the physicist does, we get a mapping of meaning that is a very good likeness of the meanings we use in ordinary life, the same vocabulary. Turns out to be the same vocabulary that has been used for thousands of years in astrology. It leads to an understanding of what the whole situation is, and through this third step that I've just taken of recognizing that purposive intelligence can invert the natural order and change entropy to negentropy, we can lay the foundation for explaining life. It would take another whole session to explain some of the intricacies of this turn, but I've at least shown the outline of it in distinguishing between the order ABC and the order ACB. So we end up, you might say, we end up returning to natural life. But now at least the formalism can keep up with what we're doing anyway. Thank you.